right, here we are, everybody. It is day 5. We're wrapping up the work week with another edition of Albert's Weather Classroom. Today's edition is Forecasting Friday. We're going to forecast together. A little different than what we have been doing over the last couple of days. It's just me. Let me show you the camera. It's just me and you, and we're going to look at all kinds of different weather links. So this isn't kind of like a presentation we saw like yesterday or Monday or Tuesday. It's just going to be me analyzing the weather with you. And included in the description on both Facebook and YouTube, there's a link, and in that link you'll be able to see all the links that I'm going to use today. That way, if you see something that you think is really interesting, which I think you're going to see some cool stuff today, you'll be able to bookmark it on your tablet or your own computer and take a look at that. So we start off every Albert's Weather Classroom with a roll call and shout outs. Look at our friends that have been watching. Keep sending me your photos. KVUE Albert, KVUE Albert on Twitter, on Instagram, on Facebook. And I've been sharing these photos on the 10 o'clock news. And then I love to kick off our weather classroom showing these as well. There's some of our friends watching over the last couple of days when we did Wednesday's Freddie the Frogcaster, yesterday's Severe Weather Day, when we talked all about severe weather. And everyone's welcome, even our friends on the couch. Everyone's welcome. I know a lot of you have been watching during lunchtime, so we're so happy that all of you have been jumping on in. I'm taking a look at YouTube here, and we've got friends from Leander and Round Rock watching. Lunchtime at a lot of people's homes right now, and I'm taking a look at also the Facebook page. We've got Kyle watching, Kyle, Texas watching. Julie is a 5th grader from Austin. We've got Cash and Grace from Rutledge Elementary. So welcome everybody, welcome on in. Again, today is Forecasting Friday. Today it's all about talking about what's happening today, what's happening in our atmosphere. And what I'm going to do today is, again, show you all kinds of different weather data. And today is kind of geared maybe for the older kids. Everyone's welcome, but there may be some information that may be going over your head. But I'm going to show you what's happening in the atmosphere locally, what we can expect, and we'll forecast together, and I'll show you everything I look at. But today's also an interesting day to talk about weather, not necessarily just in central Texas, but also across the country. Tomorrow, there could be a pretty significant severe weather outbreak, not here in Texas, but up here in what we call the Midwestern part of the United States, in particular Illinois. We'll talk about that. I'll show you some of the resources that you can look at as well. And then we'll finish up our analysis of the atmosphere with me showing you how we put it together back at KVUE. Okay, so we got a fun another little 30 minutes going on right now. There's one more link I want to show you. Let me get that going, and I will show you this. This is also, all these links I show you today are going to be included in the link, the KVUE link that you see posted in the information. If you're watching me on Twitter, I'll post it underneath the comments once this gets done. All right, so let's start off with our world. Let's start off with what's going on across the world. This is an amazing website. If you want to load it right now, you can go ahead and do it. But this allows us to see the latest satellite picture from what we call GOES 16 and GOES 17. These are the fairly new satellites, the most advanced satellites in human history, launched a few years ago, and this is what we use on a daily basis. And what's cool about this website is you can switch between the GOES 16 view, this is just the name of a certain satellite, and the satellite's position looking at the globe just like this. And then if you come here where it's a satellite, you can go down and you can load GOES 17, which is more off towards the west, looking at more of the Pacific Ocean. And look how cool this is. See the darkness? That's where sunrise is happening right now. So it's still, early morning hours, pre-sunrise out here in the central and western Pacific Ocean. Hawaii, it's still dark in Hawaii, but sunrise happening now. And you see this little feature right in here? Actually, I can draw, I think. Right in here. That is the reflection of the sun on the ocean water in the Pacific Ocean. So this is all free. Your taxpayer dollars purchase all this, so you have access to this. But what's really cool, let me go back and I'll load the GOES 16 satellite. And GOES 16 again is kind of more focused kind of in our area. And what you can do then is you can kind of just toggle in and take a look at the satellite over the United States. Let me back up just a little bit. So it'll take a couple of seconds to load it, but what we're going to be looking at here is what's happening now, and then we'll focus on what's going to happen in the future. So when I start my forecast day at KVUE and get ready, I always like to get a snapshot of what's happening right now. And the first thing I do is I look outside the window and I go outside. Going outside and getting away from the computer, even if it's just for a few minutes, especially on days when you may be expecting some severe weather, is super important. You want to get a snapshot by how it feels. Is it muggy? Is it hot? Is it cold? You want to look at the sky. Are the clouds low? Are they going to burn off? Is your forecast from yesterday correct? So going outside and taking a peek outside is always super important. So there's a look at the latest satellite picture. And what we have right now, just to kind of get your bearings straight, if you're watching me from the Austin area, we're kind of right in here in central Texas. And we've got more clouds today, right? More clouds than yesterday. There's some peaks of sunshine, but we overall have more clouds. Well, these clouds that are coming in, and we'll go back to our Tuesday lesson when we talked about clouds. These are mid-level clouds that are streaming in from the Pacific Ocean. So they're coming all the way from the Pacific Ocean and extending out into the Midwest just like that. So this is kind of a river of mid-level moisture, if you will, coming on in. That's in the middle part of the atmosphere, say 20 to 25,000 feet up. At the surface, and we'll get a little bit closer in, at the surface, or where we're at, our winds are out of the southeast, and they've been out of the southeast for about 48 hours. So they're coming right off the Gulf of Mexico like so, and that's giving us this warm, humid fetch of air off the Gulf of Mexico. So again, we'll give it a second to load. It does take some time to load because these are high resolution pictures that the satellite is taking, and it's sending it, of course, back to the internet. So that's why it takes just a second to load. But there we go. There, it's in motion now. So what's cool here on the satellite picture, and I'll clear this for you, is you can see, and this will get smoother here in just a second as all the frames load. What you can see is this mid-level cloud cover coming in off the Pacific Ocean. See that? You can even see these little wispiness. Those are little cirrus clouds, higher clouds, mid-level clouds. But if you also look closely as well, you can see these little puffy clouds. This is going to get smooth, I promise, in just a second. But these are little, small little clouds. Those are the cumulus clouds that are coming on in. Let me see if I can just stop. There we go. That will look better, I think. These little puffy little cumulus clouds, you see them showing up on the satellite too. So see these little puffy things? Those are the fair weather cumulus clouds, and those are lower clouds, and those are the ones that are coming off the Gulf of Mexico, like so. So what's really kind of cool about today is that you have different weather going on at different levels of the atmosphere. So you'll actually see the cumulus clouds, the low clouds, moving from south to north, and then the mid-level and higher clouds than that moving in from the southwest to the northeast. So you have this kind of crisscrossing of different levels of the atmosphere that's going on. So anyway, this is one of my favorite websites. You can spend hours on it. There's different filters as well that you can use. We'll back this up. Kind of in this part that you can play around with. You know, we get wildfires across the country, especially where it's super dry. We had that last year. Southern California, Oregon, Washington. There are different filters on these satellites where you can actually see the hot spots. So the satellite is so advanced that it knows where there's, it can find the heat signature. So you can actually find wildfires, and the Weather Service and Texas Forest Service uses this a lot for fires that may happen in rural areas where maybe there's not a whole lot of people, so they can respond to it. So anyway, you can have just a blast on this website. Look how quiet the Gulf of Mexico is. There's not a lot going on. So that's the satellite portion of it. That shows us where the clouds are, and you saw just how cool it is where you're not just seeing where the high and mid and lower level cloud cover is, but you can also see where sunrise is occurring, and even the reflection of the sun. Anyway, as a weather geek, this is some of the coolest stuff ever. I remember when I was in 7th and 8th grade, so we're talking like mid-90s, and I was able to see water vapor, which is a type of satellite, for the very first time on dial-up internet, for those who are old enough to remember that, and being blown away that it was one single image of that. And now you all that have any kind of interest in meteorology, you have everything at your fingertips. Everything that we look at on a daily basis, you can get it free at your house for the most part. Okay, water break. So once we take a look at the satellite, let's take a look at what we call the surface map. This is what a surface map looks like. Again, all these links that I show you today, they're in that KVUE.com link that's embedded within the story in YouTube and Facebook. So it's all there for you if you want to follow along at home. So this is the surface map. And the surface map gives us a quick idea of what's going on across the country right now. So again, Austin, Central Texas, right in here. There you see Texas, right in here, right? So we'll clear that. So what's going on right now is we talked about how where we are here at the surface, where we are here at the ground, the wind is out of the south and southeast. And you'll see these little weather stations here. These are current conditions, or at least when this map was produced. And this is really neat to look at as a meteorologist because you can get a ton of information in a short period of time. My friend's saying my audio's staticky today. Yeah, I don't know. I have some kind of interference a little bit. So I guess I could, let me try changing microphones and you all let me know on, I'm looking at Facebook Live. Let me know if this helps at all. Stand by. Oh, I don't think I'm gonna be able to do that. All right, so sorry it's staticky. It's just this lav microphone. Maybe if I tighten it, it has some kind of interference. So apologize for that. If it's super terrible, then I can jump off and do it again. But yeah, I don't think I have access to any of the mics right now. That stinks. What if I do this? Stand by, everybody. Hang on. We're gonna see if we can make this better. Yeah, I don't have any access to that. Actually, if I did this. Oh, technology, you're fun. Okay, cool. How does that sound? Does that sound better? Let me know. Sounds fine to me, Tanya says. I'm using this microphone now. Microphones sound better. Check 1, 2, 3, 4, 5. I know there's a little delay on Facebook Live, but hello, hello, hello. Different microphone. Hopefully it's not staticky. Check, check, check. I'm just waiting for the comments to flood in. Okay, cool. So thank you, Kathy Rutherford. Same, but thanks for trying. It's a little staticky. Huh. Well, okay, so I'll tell you, there's so much equipment in this little small room here at my house to get us on TV that there's just some kind of interference. But okay, we'll continue. We'll continue here. So back to this, what's going on. Again, surface map, you'll see these little weather stations right in here. And these little weather stations are telling us all kinds of different things. They're telling us the current temperature, the current dew point, or a measurement of moisture in the atmosphere, sky cover, is it cloudy, is it clear, and as well as wind direction and wind speed. And you can tell that all from these very little tiny things. Let me see if I can zoom this in and I'll give you an example. So we'll zoom in as much as possible. And this is something that you'll learn in meteorology school if you go to it. So this is a weather station probably from, I'm thinking San Antonio, this little guy. So that's just one little weather observation of what's happening right now. In red, this top number kind of to the top left of this blue thing, that's a look at the current temperature as of the printing of this map. So 66 degrees and the dew point temperature was 66. So the temperature and the dew point were right on top of each other. They're matched up, so that means our atmosphere was 100% saturated, 100% humidity. So that gives us an idea of temperature and dew point. This little guy right here, the little circle, once it's filled in, that means it's cloudy. If it's open like this, it's clear. So that can give you an indication of what the sky looks like across the state. And then these little bars that look like that, that shows us which direction the wind is coming from. So that's saying the wind's coming in from the south, and the little notch there shows that it's 5 knots. This longer one that you kind of see right here, that's 10 knots. And then you see this one right here, it's long, and then a short one, that's 15 knots. So for an example, we'll take a look at this one from Lake Charles. And in Lake Charles, 71 degrees, dew point of 68, the wind out of the southeast, it's cloudy, and the wind is at 5 knots. So that's how you read those little quick weather stations right in there. So that's kind of a surface analysis. I'll back this up so we can kind of find out what else is going on in the atmosphere. And I need to get going here. I got a lot to show you in the next 15 minutes. So also on this map, It's showing us what's happening at the surface when it comes to front. So we've got a frontal boundary that's out here in Colorado and New Mexico with an area of low pressure. Low pressure means there's not a lot of force going down. There's upward motion in the atmosphere that allows for little parcels of air to go up, create clouds, create rain, create thunderstorms. So we got a front out towards the west. This is the one that will move in Austin tomorrow morning. There's a stationary front up here towards the north. That's not impacting our weather. This little thing right here that you see that's got little bubbles, that's what we call a dry line. It's like a front. A front separates, at least a cold front separates cold air from warm air. A dry line separates dry air from humid air. And the reason why it's so much more on the humid side ahead of that dry line is the wind. It's all out of the south, right off the Gulf of Mexico. So let's go to the next one here. This is just another way for you to analyze what's happening right now. We looked at first a surface map, what's happening where we are right now. This is showing us what's happening higher up in the atmosphere, about 20 to 25,000 feet. This is in your links area. This is what I'm calling water vapor 500 millibar analysis. So again, this is kind of showing us what's happening in the atmosphere. The white here is showing you moisture, mid-level moisture, and we saw that we have all that moisture coming in off the Pacific Ocean. And what's cool about this too is it puts these lines here, and these lines here indicate for us where there could be troughs of low pressure or storm systems or ridge of high pressure or quiet weather. So whenever you get this little dip like that in the jet stream, that's what we call a trough of low pressure. And whenever you get a little ridge or a little hill like that, that's a ridge of high pressure. So trough out here towards the west, ridging off towards our east. And high pressure means that you have sinking air that suppresses not just rain chances, but even cloud cover development. So sunny and hotter weather associated with high pressure, cooler and wetter weather, stormy weather associated with low pressure. So here's our storm system out here towards the west. Really quiet weather across the Gulf of Mexico with high pressure in place. And it's this storm system out towards the west that's going to be a big troublemaker tomorrow for the Midwestern part of the United States. This storm system is kind of moving up like this, and this is going to be a severe weather maker for tomorrow. It's going to stay to the north of central Texas. There's central Texas where the X is. So we just kind of get a quick little chance for passing showers late tonight into tomorrow. But I'll show you here in just a second that that area of low pressure out towards the west is not going to be good for our friends in places like Illinois and Missouri and Indiana. This is another link that I provided for you, weather.gov/radar. I know a lot of you may like apps and stuff for radar images, and I guess they're kind of fancy and stuff. I don't prefer them. I want to see like real-time radar. There's a paid-for apps that you can have, like Radar Scope, that's really good. It costs a few bucks. There's another one called Weather Lab that costs just a couple of bucks, and those guys are based out of here in Austin, and that's a pretty sweet app too. If you don't want to spend money and you just want to be able to look at radar, I think the website from the Weather Service is the best one. I have to say KVUE.com as well, but you know, if you really want to get into this, I'm telling you, go to weather.gov/radar. So you can take a look at a higher resolution version of the United States map by clicking that, and you can see kind of what's going on. We've got some thunderstorms here in Oklahoma. We've got some showers and thunderstorms here in Indiana, starting to rain in Indianapolis right now. We're all quiet. And if we go back, you saw where we have some of that active weather right now. You can actually come and pick the Indianapolis radar. There you go, and actually see a high-res version of it. So yeah, it's not as fancy as, you know, some of these apps and stuff, but this is going to be what we call level 2 radar. It's not going to be this, you know, like on some of the apps, they're very smooth looking and they're very blobby looking on the radar. This is actually going to show you what's going on. And then you have a lot of products that you can use here and loop even the radar. You can look at storm relative velocity. That will show you which direction the winds are blowing within the storm, and it takes account the forward motion of the storm. That's great for tracking straight line winds and rotation and tornadoes and stuff like that. So lots of cool products there. Again, there's a lot of paid apps that you can get even more products. Radar Scope or Weather Lab allows you to look at different levels of the radar scans. So if you have some more questions on that, just hit me up on social media and I'll tell you more about that. Okay, so let's talk about that severe weather risk tomorrow for the Midwest. Here's the next link, sbc.noaa.gov. Again, this is all included in that link that I have in the description All these are in there. So the Storm Prediction Center, this is an awesome, awesome website. If you're just now getting interested in weather, I don't care if you're in elementary school or high school or college, this is something that you want to look at, especially now through the first part of summer, because we're getting into spring severe weather season, and you'll learn so much from this website, and there's so much good information. So the first thing we're going to look at here is convective outlooks. So every day, the weather experts at the Storm Prediction Center, this is under NOAA, the National Weather Service, based out of Norman, Oklahoma, they provide these convective outlooks. Convective meaning thunderstorm outlooks. And they have these high resolution ones that go out today, tomorrow, and day 3. And then they even have this 4 to 8 day outlook that you can look at as well. And this can give you an early heads up on severe weather that may be headed our way or somewhere else in the country. So you can kind of click on this convective outlook. Some of you may already be familiar with this, but you can overlay counties, you can overlay cities, higher population and stuff like that. And what we're looking at here is a scale from 1 to 5. So let me go back to my presentation here and I'll show you. So it's a scale from 1 to 5. This is what they're forecasting, right? There's a 0, if you will. It's just a general thunderstorm chance, you know, no severe weather, just there's a chance for some cloud of grand lightning, maybe some heavy rainfall. And then you get into the severe weather chances that goes from 1 to 5. 1 being the lowest on the scale, what we call marginal. Then it goes 2 out of 5, that's slight risk. 3 out of 5, that's enhanced risk. 4 out of 5, a moderate risk. And 5 out of 5 is the highest risk that there is. So it goes from isolated severe to widespread severe on this particular scale. In Central Texas, we'll get marginal and slight dozens of times a year, right? We'll get enhanced, I'd say maybe a half a dozen times a year. And moderate risk is pretty rare for us. If we have a moderate risk, we're going to be staffed up at the station big time. I'm trying to think the last time, maybe once every year, something like that, or every other year, something like that. Since I've been here at KVUE, and I'm going on 10 and a half years, I've never had a high risk here in Central Texas. So this is super, super rare for us. So that's, again, the scale. Think of 1 out of 5, 1 being the least chance of severe weather, all the way to 5, huge, huge chance. So tomorrow, today, I should say, today there is a slight risk, so 2 out of 5 risk for severe weather from Kansas to Missouri to Illinois to Indiana. That's in the yellow. In the kind of darker green, that's that marginal risk, that 1 out of 5 today. That includes just north of the hill country, San Saba, McCullough County, up around Brady, and San Saba, the community of San Saba, that goes to Wichita Falls and extends all the way to Columbus, Ohio. Tomorrow, though, let's take a look at that. There's a look at kind of a closed-in version of today's outlook. Tomorrow, severe weather risk will all be off to the east of us. This light green for Texas is just to account for a general thunderstorm. That's kind of that 0, if you will, the no severe weather risk here. But I want to show you what's going on in the Midwest. So this is where there is that severe weather risk today. In yellow, it's slight, a 2 out of 5. Kansas City is included. Good chunk of central Illinois, Indianapolis, and Indiana also included. So a 2 out of 5 risk for severe weather there. But look what happens tomorrow. So Saturday, they have yellow, they have orange, and they have red. So they have slight risk, 2 out of 5 risk. In yellow, that's an enhanced risk, a 3 out of 5 risk for severe weather. And then look at this, a moderate risk. So this changed from this morning, moderate risk of 4 out of 5. And the National Weather Service is saying in this part of Illinois, they're saying large, this is what they're saying, large to giant hail. So we're talking about larger than golf ball. I don't think I've ever heard them use the verbiage giant hail before. And then also the potential for supercells or singular powerful thunderstorms that could spin up some tornadoes. So again, that's in Illinois for tomorrow. We'll go back to the Storm Prediction Center website. And again, we're in the convective outlook. And if you come here to day 2, this is for Saturday, you can see where that moderate risk is. And then you can see the percentage, the chances of tornadoes, which is up there, 15%, which sounds small, but that's pretty significant. Damaging wind threat, moderate, and then a pretty significant large hail threat in that part of the country. And if you're interested in this, again, you can look at these maps, and then the Storm Prediction Center meteorologists have a whole write-up here of what they're expecting to happen. And this is where I got that large to giant hail. There you go. Large to giant hail is possible with either left or right splitting supercells. So you can get a lot of cool information here if you're interested in meteorology. This stuff may be over your head a little bit, but then if there's like a word that you're unsure of, or what does that mean, you can always Google it and find out, right? Okay, so let's go now to models. So I'm going to show you a couple of models here. I'm just checking in on everybody. Amy's asking, on that map, can you get down to zip codes? No, you can get down to counties. So as long as you know where you are in the county, you're going to be able to do it. Someone says, stop the angry faces. Someone's not a severe weather fan, apparently, on there. Okay, so let me show you models. Again, this link, Texas, txtornado.net, available in the KVUE link that I'm providing. I look at this every single day. This website was created by a meteorologist with the National Weather Service. I think she's still down in Corpus Christi. It's just out of habit. I like it, but it's basically, she just set it up where all these links are really easy to get to, and it's free. All this is free. So the two that I look at multiple times a day is the 10-meter winds, what winds are going on at 10 meters above the surface, and I look at what's called 500 millibar vorticity. This shows me what's going on in the mid-levels of the atmosphere. So the first thing, let's look at this vorticity first. So I'm going to use the GFS model. This is the American model. You hear us talk about that on TV a lot. And let's see if this loads. It'll be hilarious if this website doesn't work right now. It's okay, I got to back up. Oh, look at us. All right, maybe it's because I'm using an old one. Oh, there we go. Okay, our lucky day. So 327. Perfect. Okay, so this is a fairly new one that just came out, right? Today's the 27th. Yeah. Okay, so this gives me an idea of what's going on mid-levels of the atmosphere, 20 to 25,000 feet, what the winds are doing. But then you see these brighter colors. This shows me what we call vorticity, or that motion upward in the atmosphere. And motion upward in the atmosphere, you need that for thunderstorm development, rain development, and potentially for severe weather. So just to get your bearings straight, here I can make this a tad larger too for you. Okay, cool. That actually, I need to be able to see the date. Okay, so yeah, that works for me. Okay, so move my webcam. There you go. Okay, so just to kind of get your bearings straight on where we are, Texas is here, Central Texas is right there, right? Here's the Gulf of Mexico, right in there. So what we have is we have that dip in the jet stream, just like that. Remember, we talked about the dips in the jet stream is low pressure. Low pressure allows for natural motion upward, allows for clouds, rain, thunderstorms. So that's what we're looking at here. You've got a big area of high pressure centered right over the Gulf of Mexico. That area of high pressure, sinking air, right? Suppressing rain chances and cloud cover development, sunny weather. That's why there's very little in the way of cloud cover anywhere in the Gulf of Mexico. And then these low pressures, it's a pretty aggressive little system. On the nose, or kind of on the leading edge of it, kind of right in here, you'll get the maximum amount of upward motion. So here's what's going to happen through time. What we're looking at here is a computer simulation of what this particular computer model thinks is going to happen over the next several days on how this storm system will develop. So we'll kind of go through time, and let's go through tomorrow morning. And tomorrow morning at 7 a.m., this area of low pressure, again, Austin area is kind of right in here, stays to the north of us. So that's why I'm not excited about us locally getting a lot of rain or even a lot of thunder. It'll be a quick band of some showers, maybe a rumble of thunder as this kind of pushes a front through our area. But the maximum amount of force in the atmosphere, the maximum amount of upward motion is going to stay well to the north of us. And that's why that severe weather risk is well to the north of us. So let's go to, this is 24 hours out in the future. We'll go to 30 hours out in the future, and then 36 hours out into the future. So this is tomorrow evening. And tomorrow evening, we're quiet. The area of low pressure is kind of right in here. Frontal boundary will be kind of right in here, and then you'll get a warm front kind of right in here. So we'll kind of draw that just like that, okay? So area of low pressure, again, that's that rising motion in the atmosphere. There's not a whole lot of force downward. What you'll have with areas of low pressure is air that is spinning counterclockwise here in the northern hemisphere, right? So when we talk about counterclockwise, we mean that air kind of comes in like this, and the air that kind of goes like that. So with that being said, on the front of these areas of low pressure, because you have counterclockwise rotation, you'll get warm tropical air off the Gulf of Mexico to come in on the heart or in the nose of these lows. And on the backside of these lows, you get dry and cooler air. So that's why when these areas of low pressure begin to move away from you, things will start to at times cool down, and then you'll get that drier air on the backside of these lows. So if we look at this map, the overall best chance for severe weather, again, is going to be kind of right in here, right? Because you've got that moisture coming in from the south, and then that dry stable air on the backside of it. So that's why there's that severe weather risk on the nose of that low tomorrow in Illinois, in portions of Missouri, and also into Indiana. So let's go out a little bit further up. Let's go 42 hours. That's tomorrow night. This is a look at Sunday morning. That area of low pressure is focused in over the Great Lakes. And then as we go through the rest of this period, it kind of gets a little bit weaker and moves into the northeast. This is a look at Monday afternoon. And for us to note, on Monday afternoon, there's the area of low pressure that we were just tracking that's going to create severe weather tomorrow in the Midwest. Notice we have another disturbance coming in. This one not as potent, not as strong, but this will also dive a little front through our area here in central Texas and allow for a chance of rain on Monday. This is a look at 78 hours out. There's 84 hours out. This is a look at Monday evening. Notice how that area of low pressure kind of skirts to the north of us. Not as far north, but to the north of us. We'll kind of go through the end of this period. We'll go to Thursday evening of next week. Pretty quiet, tranquil weather pattern for us. There's no big, huge dips in the jet stream, but at the same time, no big ridges, no big areas of high pressure as well. Big area of low pressure up here in Canada. 240 hours out, and we'll kind of go to the rest of that period. And there you go. So that shows as we go to the end of this model, which is on Tuesday, April 7th, we get another big area of low pressure developing Southern California and the Baja, and that could bring us a chance of rain as we head into the second week of April. So that's one model that we look at. Again, we were looking at mid-levels part of the atmosphere. I really like to look at that. Kind of gives you a quick overview of what's headed this way and stuff like that. And then you can look at more of a surface-based one. Wow, it's already 12:30. Oh, we're going to go just a little bit longer today. If you're enjoying this, stick with me. But the surface-based one that you have access to as well is going to show you in green precipitation. You get these little blues. It shows you where there's some freezing and there's pressure lines, highs and lows and stuff. It's a lot of stuff here, but I like to look at this one to look at rain chances. So small chance of rain tonight. Pretty quiet for the second half of the weekend. This is showing that chance of showers on Monday over Texas. Tuesday on this particular model is pretty quiet. Let's kind of go through this period. This shows us Thursday, April 2nd with a chance for maybe some showers. Pretty good looking front up there towards the north next weekend with some showers late Friday into maybe early Saturday. And this model, as you go farther in time, gets a little bit more inaccurate, and it always gets quite stormy whenever you go this far out. We're 252 hours out in the future on the evening of April 6th. So again, that's just the GFS model, the American model. We look at all kinds of different models. There's another one that I like to look at. It's the European model, which just seems to be a little bit better. You can have access to this. There's some websites that now have it free. Weather.us has the European model, or the ECMWF, Pivotal Weather. If you Google Pivotal Weather, you can also get that for free as well. I'm using our Weather Vendors website here, and this shows us pretty much the same thing. This is a look at tomorrow morning. Big area low pressure here, thunderstorms developing here. Let's go to tomorrow evening, area low pressure here, thunderstorms on the nose of that low. So see how the models, even though they're two different models, the simulations are right on track, timing and intensity. We like to see that. We like to see consistency in the models. That gives us confidence in our forecast. Sometimes one model can say one thing and the other one will say the exact opposite. And that's when we're like, 50% chance of rain. So that's where it gets difficult. And that certainly happens around here. So we'll just kind of go through the European model here. This is a look at Monday morning, Monday afternoon. There's that chance of showers, central Texas into North Texas. On the nose of that low, some thunderstorms in northeast Texas for Monday evening. And then we'll be on the drier side of the low, right? We'll be on that drier side of the low. Stable air comes in, and then we'll have a quiet Tuesday. Probably a lot of sun Tuesday, mostly sunny Wednesday. Southerly winds return off the Gulf of Mexico next Wednesday. Off the Gulf of Mexico next Wednesday. So we'll get a little bit more moisture, more cloud cover. See if we get any other big rain chances. Southerly winds continue. There's a look at Friday, next Friday, a week from today, showing that chance of showers. Remember, the American model was saying the same thing, so I like that. We got some consistency there, showing a chance for some showers next Saturday. This one's pretty aggressive on a chance of thunderstorms early Sunday morning, a week from this coming Sunday. So and there's a big trough. Look at that, just like the American model, big trough of low pressure towards the end of the period, developing Southern California into the Baja. So again, today is kind of different from the last several days. It's just me showing you what I look at and sharing my links with you. This is what I do every single day, is just kind of look at all these models and I try to get what I call a weather story in my head. That way, because I don't have a teleprompter on TV, I'm just talking just like this. And if I look at all this kind of stuff and I kind of put my forecast together, it helps me be able to tell that weather story. The next link on the list is observations. I'm going to wrap up here in 5 minutes, everybody, because I don't want to go too late, because I know some of you have stuff to do. And I just took my sweet time today, and I could talk about this all day long. But this is a look at observations here in Austin. And the cool thing about it is you can enter any kind of location here, and it's all based on airport codes. So we know that the Austin Airport, Austin Bergstrom International, is AUS, KAUS, that's the airport code. Camp Mabry, that's what we forecast for because it's closer to the city of Austin, is KATT. You can do DFW, which is Dallas. You can do HOU, which is Houston. You can do Chicago, ORD. If you know the airport code, you can plug these in and take a look at this. But this is just showing us observations over. Wow, it looks like Camp Mabry hasn't reported since yesterday afternoon, or they're having some connection issues here. But we'll type in the Austin Airport, AUS. This is Bergstrom, and Atlanta. Yeah. Anyway, but if you know your airport code, you're good. Also provided you a link on the climate data, the almanac, the highs and lows. You can get a look at the averages, the average low, the average high, the records. That's a cool website. This one also super cool. We love this one because you can go back and take a look at the calendar. What was the high yesterday? What was the high, a week ago? It was 85. How much rain did we get? So that's provided in the links section. Probably not going to have enough time to talk about this. We'll talk about this next Friday for Forecasting Friday, but this is the MOS. This is Model Output Statistics. So we showed you models graphically with the map and the colors and stuff. This is a way that you can look at it more of a data look. I write down these numbers, at least some of these numbers, every single day because I like to see how models are performing. Some models will be better ahead of fronts. Some models will be better behind fronts. Some models do better in the spring. Some models do better in the summer. So you get a forecasting experience, but model output statistics, we'll go back to the GFS, the American model, is showing me the minimum low for tonight. So this model is saying it'll be 59 tonight in Austin, 79 for tomorrow night 51, that'll be nice. And then for Sunday, 77. And then you can look at temperature broken down by every 3 hours here. Dew point temperatures, that's real nice too. So we're super humid, dew points in the 60s. And then behind that front, dew points in the 40s. Tomorrow afternoon, upper 30s and low 40s for dry air. Ooh, that's gonna feel nice tomorrow night. Sunday's looking awesome too. Jeez. Cloud cover. So we've got broken clouds, partly cloudy if you will. And then we're overcast in the overnight. And then we'll clear out throughout the day tomorrow. So this is showing me morning time. This is all in UTC or Universal Time Code or Zulu time. Again, we could literally spend a whole lesson just how to read this, but I just want to give you a quick look at what I look at every day. Here's another model output statistic. This is the NAM, North American model, and then this is the GFSX. This goes out 7 days. Use this a lot for the 7-day forecast. One of many things we look at. If you are super interested in wanting to learn how to read these, reach out to me and I'll send you a link on how to read this. And I'll also include it as well. But it's another cool website to look at. At the end of the day, I'd love for you to look at my forecast. But if you're doing some traveling outside of Austin, the Mets, the meteorologists at the National Weather Service, you can't beat them. They're great as well. And they put out these zone forecasts. This also included in the link section. Zone forecast. So this is their forecast, all in text. It's not, pretty 7-day and stuff like that, but it gives you exactly what you need for the next 7 days. Love that. And this one, okay, I'll leave you with this. This is also provided by the National Weather Service. If you are interested in meteorology, and if you're middle school to an adult, and you just want to learn more about what's happening in the atmosphere, what's going to happen, and learn some vocabulary words, I tell my interns, read this every single day. You read it every day, you'll start to develop muscle memory on what stuff is, and it's good for you. So this is what we call the area forecast discussion. This is a long, almost like a research paper of what's happening in the atmosphere that is made by at least 2 meteorologists at our local weather service. Every weather service office across the country provides this, so if you are interested in finding out what the folks in Chicago are thinking about the severe weather chances for tomorrow in Illinois, you can go look at theirs. But this is really cool. And again, the link is provided for you. But this is, if you're into aviation, they have an aviation section here. This is a short-term forecast. And what's cool about this is if you read it and you're like, wait, upper level, what does that mean? You can click on it and look at this. It's going to give you the definition. Or you're like, what's instability again? You hit that and you got the definition. So you can learn just so much by reading this on a daily basis, and I love it. And then you have the forecast here at the bottom. So anyway, today's Albert's Weather Classroom, a little bit different than the last ones. As we talked about at the beginning of this series, that I wanted to be able to make sure that all ages were able to get in on this. So like our Monday lesson, and all the links on past lessons are there, right? Monday's lesson, Introduction to Meteorology, everybody's welcome, but geared for elementary and middle. The atmosphere, middle to maybe intermediate, kind of junior high. And then we did Reading Wednesday, that's for, the pre-K and even younger. And then yesterday was a little bit more advanced, kind of junior high to even high school. And then today was high school to college. So if you're wondering today, why is he going way in depth and all this kind of stuff? That's the only reason. I want to make sure that we're covering all ages in this weird time that we're in, where we're all stuck at home. And also wanted the adults to be able to, those that are interested in weather, be able to enjoy, like today. Kind of just did kind of a analysis of the atmosphere and show you what I'm going to look at today. Okay, so I'm just looking at some of your comments and stuff. We went 43 minutes today. Send me your photos of you watching. I would love to see photos. If you've got like an older kid, like a high school kid or a college kid that watched today, I'd love to see a photo of that, and I'll totally share it on TV, because we got all these little cute little kids, but I want to see somebody with a beard watching Albert's Weather Classroom. I think that'd be hilarious. Okay, everybody. Owen from 3rd grade. Owen, I hope you enjoyed today. We got into it today, didn't we? Adam saying, how do you figure the percentage of rain chances? Adam, a combination of 2 things. We're looking at the models, right? The different models graphically, like we looked at the GFS, and I'm also looking at that text, that model output statistic, the one with the blue screen. So how I do it for rain percentages is if, let's say I'm looking at 3 or 4 different models, and they all have the same thing. They're all exact timing when the rain's going to start, intensity of the rain, they're all on the same page. That gives me confidence as a forecaster to go 100% chance of rain, right? It doesn't happen a lot when all models are locked in step. It doesn't happen a lot. A lot of times one's doing this and one's doing that. So you take a combination of 2 things when you do a percentage. One is going to be confidence. Confidence in your forecast is a big one. And the other one is coverage of your area. So that's how I do it. So if one model says, this is just very elementary, right? Just to kind of give you an idea. If one model says widespread rainfall, everyone in the area gets rain, 100%, right? The other one's not in that same book either. What are you going to do? You're going to split the difference, right? 50%, right down the middle. But then confidence comes into play. I'm thinking, well, the one that's really wet for tomorrow has actually done really great this entire spring. As a matter of fact, it's done really great even in the winter. So I have a little bit more confidence in that model at the end of the day. So instead of going right down 50%, I'm going to give it a 60%, maybe even 70%. So that's where intuition and forecasting every single day and having a snapshot in your brain of what the weather has been like in the last several months, experience and forecasting for a certain particular area comes into play. So I know that was a really long answer to that. Yeah, shout out to Mark Murray. I talked to Mark last week. Mark's doing good. Mary's asking, has Austin ever been in that high? Going back to the SPC. I believe it has, not since I've been here, but I remember the warning coordinating meteorologist at the Weather Service saying that part of our area has been. I don't know the exact date. It hasn't been since I've been here. Okay, so I was looking at Facebook. We still got 81 people today. I think we lost some viewers today. I'm looking at YouTube now. How many times is your forecast accurate? You know what? We do. People remember the times where we have egg on our face, but that doesn't happen that often. People, don't realize how great the science and technology has come. And I'm not just, tooting our horn as a meteorologist. I always give credit to technology, to the models, right? To the research that meteorologists outside of broadcasting do. So when the models are hitting on all engines, timing of storms, intensity of storms, accumulation of rainfall, you give credit to the technology, right? It goes the other way too. If the models miss it and it's like, well, those darn meteorologists, they missed it again, you got to give credit and you got to give blame where that's due. So yeah, and the cool thing about it is we all look at the same thing. It's comes down to, I think, experience and also intuition in some of these cases. Bass Blue's asking, Beth in 5th grade, what is your favorite tool to forecast the weather? You know what? We'll go back to that. We'll go back to this. And again, I think I put this at the very first link. I love this website. This is like one of my favorite websites. We'll load the Go 16. To forecast kind of what's happening right now and get a beautiful snapshot of what's going on planet Earth. It's just really, really neat. And there's so many other little layers that you can add here. You can play with this for forever. So I like to look at that first thing in the morning too. I like to kind of just get a quick snapshot of this because this can tell me pretty quickly what's going on what's going on with the atmosphere. But even like this, check this out. So we talked about how the models can be kind of all over the place. And this is just a sample. It can be even more widespread than that. The GFS, the American model, is saying that tonight's low in Austin is going to be 59. Meanwhile, the NAM is saying 64. So there's a 5-degree difference. And sometimes there'll be a 10 to 15 degree difference in this data. So this is not, sometimes it's not as easy as it may appear. I'm just trying to see if there's any other big discrepancies and stuff. Especially if you go like 4 or 5 plus days out, they'll really start to diverge. But that's just the nature of forecasting in the year 2020. It's getting better every single year. And that's why if you are interested in meteorology and you're a young person, you're going to be that next generation for research and to implement more technology. And weather forecasting is just going to get better and better every single year. Chelsea says, please answer my question. How do you track tornadoes? And my sister knows you. She was on the new for her gold award. Oh, okay. Hi, Chelsea. How do you track tornadoes? We're going to use radar for that. First of all, we'll have these outlooks like this that gives us an idea that the atmosphere may be primed for severe weather, hopefully days ahead of time. But we'll use Doppler radar just like this. Radar is ground-based, so it's sending a little piece of energy out there, bounces off a raindrop or a hailstone or even debris. So we'll use radar to find out what these storms look like inside, if there's tight rotation in the storm. And what's cool too is with technology, These radars are sending out a beam horizontal and vertical, and it can actually detect what a raindrop looks like, what a hailstone looks like, or even what debris looks like. So if we have a signature on radar and we have tight rotation, and then we use this other product called correlation coefficient, we can actually see if there's lofted debris or debris being picked upwards. Technology is just wacky. It's just so good right now. All right, so that does it for me. We did 50 minutes of Albert's Weather Classroom today. We're back on Monday. Monday's presentation is Career Day. If you have interest in being a meteorologist, we'll show you all the different jobs that you can have. It's not just the broadcast. There's the researchers, there's the professors, there's the private sector, there's the meteorologists with the National Weather Service that we rely on so much as well. All right, everybody, have a good rest of the day and have a good weekend. We will see you Monday.